This video goes over question 7 of the derivatives from the definition. Homework. Suppose an object moves along the y-axis so that its location is y equals f of x equals x squared plus x at the time x, y is in meters, x is in seconds. Find the average velocity, average rate of change of y with respect to x for x changing from 3 to 7. The average velocity for x changing from 3 to 3 plus h, and the instantaneous velocity at x equals 3. So I'm going to do that by hand here. So the average rate of change, the average velocity, I'm going to call it VAV, is going to be f at 7 minus f at 3 divided by the time change 7 minus 3. So if we put in 7 for x, that's going to be 7 squared plus 7 minus 3 squared plus 3, all divided by 7 minus 3, which is 4. And this is going to be meters, and this is going to be seconds. So that's 49 plus 7, which is 56, minus 9 plus 3, which is 12. And this is meters divided by 4 seconds. So that's going to be 44 meters divided by 4 seconds, or 11 meters per second. And we could do this in the calculator as well. I'm going to start a new problem, doc for 1, put in a graph, x squared plus x. Save that. Then I'm going to go to a calculator page and do a fraction and say f at 7 minus f at 3 divided by 7 minus 3 is 11. So 11 meters per second. Excellent. The average velocity is, so we're doing from 3 plus h seconds to 3 seconds to 3 plus 8 seconds. So we're going to say VAV equals 3 plus h squared plus 3 plus h minus 3 squared plus 3 all over h, because 3 plus h minus 3 is going to be h. So if we distribute that out, that's going to be 9 plus 3 plus 6h. 6h plus h squared plus 3 plus h minus 9 minus 3 all over h. So we can cancel out the 3's and the 9's. So that's 6h plus h squared plus h all divided by h. So we can cancel a single h everywhere to 1 here. So that's going to give me 6 plus h plus 1, or 7 plus h. And so let's put that in. Fantastic. And then instantaneous velocity is, I'm going to go back to the actual definition. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Substituting in, f prime of x equals the limit as h approaches 0. So this is going to be x plus h squared plus x plus h minus x squared minus x all over h. Distribute out the binomial squared, x squared plus 2xh plus x plus another h minus x squared minus x all over h. We can simplify. X squared minus x squared is 0. X minus x is 0. And we're left with the limit as h approaches 0, 2xh plus h. Should have had an h squared somewhere. Plus h squared plus h squared plus h all over h. We can cancel out 1h everywhere. This becomes 1. So we get the limit as h approaches 0 of 2x plus h plus 1. We no longer have a problem with dividing by 0, so we can let that h go to 0. And our final derivative is 2x plus 1. And then if we substitute in 3 for 2x plus 1, we get 6 plus 1, which is 7 meters per second. Well done. And that concludes this video.